Hi, my name is Andy Quass. I'm a senior NG fellow at Northrop Grumman Corporation. I've been with the company 46 plus years and have been doing satellite developments for a good part of 5 decades. I actually have 2 extra years experience, so 48 years in this business. And I got to say that, this is such an exciting time for space. We've built satellites in the past where we have, developed them and sent them to space, and they're pretty much a one-shot deal. You take them to space, they hopefully work. If they don't, if they do, you use them as long as you possibly can, but you have no chance to make any changes. Things have changed now with the Northrop Grumman subsidiary Space Logistics, which has developed over the past 10 years a very robust space servicing cadre of satellites with a lot of good experience brought into that. This new market of exploiting this new technology is pretty exciting, something you're all going to really enjoy. I first want to thank the students and professors that are considering doing the C3 track for on-orbit servicing. I think you're going to find it to be very exciting and very challenging and very rewarding. This new market allows us to take that paradigm of building a satellite that you're going to use. Once it's gone, to be able to make modifications to that satellite or fix things once it's in orbit. That's something that's pretty darn new, and we're excited about the potential of that being for our industry. Northrop Grumman and Space Logistics in particular is the leader in this. We've done it several times now, and people are identifying the work we've done as critical to the ability to do space servicing. Hopefully by now you've looked at the ISAM Cosmic video, which shows in various ways that you're able to modify satellites that are in orbit. We're focusing right now on geostationary satellite orbits. But with the mission extension vehicle, our first vehicle that flew in 2020, the first time we've actually in industry been able to go up to a satellite, in that case in the graveyard orbit, pull it out of that orbit. It was there because it ran out of fuel, basically. The sensors that were on board were working fine, but without fuel, it couldn't maintain its orbit that it had to do. So it limped its way into the graveyard orbit, and we went in and got it. Brought it out of that graveyard orbit, put it into a different orbit, and continued that mission for 5 extra years. Big difference than having to buy a new satellite and start from scratch. The mission extension vehicle, revolutionary for its time, and everybody said, okay, you got lucky, you did it once. But a year later, in 2021, we did it again with another satellite. And this time, it was with a satellite that was in a operational orbit. And we attached to it, relocated it, managed to have all the sensors still working. And for that particular owner of that satellite, it's working fine again 5 years later. Everybody said, okay, you've pulled it off twice, but to be true servicing vehicles, you have to be reusable. And so we, at that point, at the end of the 5-year mission of extending that particular satellite, deactivated or separated from that satellite and went over to another satellite and connected to it. And we just did that earlier this year. So checking all the boxes. Can you do it more than once? Yes. Can you do it with the same vehicle, servicing vehicle with a different satellite? Yes. And so mission extension and mission servicing is now become a reality because of the work that Space Logistics has done. And that's what we're going to challenge you guys to do. What is relocation on a mission extension is important with the MEV. Another version of that is the MEP mission extension pod that we're developing right now that is attached to a satellite and for similar propulsion purposes stays with that satellite. We also are developing a mission robotics vehicle, and that opportunity will fly early next year, 2026, and it will be able to do repairs of satellites, replacing components on satellites, maybe upgrading a particular component. Let's say a satellite built in 2015 is kind of using technology from 2010 in a processor or any particular item that's on board, and it's time to upgrade it. We will be able to go in and replace many of the components that are on board current operational satellites, and including in all that is the ability to just go in and refuel. So we're looking at that. And then the ultimate goal in the long term is to be able to assemble in space. And that pays off in satellites where they're really too large to fit inside a shroud for a launch vehicle. And so we'll take up the parts and assemble them actually in space. And now the product that we're making can be unlimited, because it's just a matter of us moving different locations and making the assembly. That's a little bit farther out, but it's in our purview to be able to do with these vehicles that we are developing right now. So that's really up to you now to, if you choose this particular program, to design what you consider the optimal space servicing vehicle. Some of those features might be robotic arms. MRV has 2, maybe 1 should be the right number, maybe 3. You decide. Maybe it has refueling ports on board, has to have some way to grapple effectively a prepared satellite, a prepared client that the future satellites will be. Maybe it's used for debris removal and the ability to grab some items that are, bad debris areas, and we can clean up space. So a lot of different opportunities. And part of what you're going to decide is what those opportunities are. Whether you want to start with a clean sheet of paper, that's fine. If you want to leverage off existing satellites, doesn't even have to be a Northrop satellite, but I'd recommend it. Or, we've talked about the possibility of just using an ESPAStar. And also, you should consider, if you looked at that cosmic video, you saw that there were gas stations along the way of a car when it's going across country. Well, in this case, we're going to eventually have things called persistent platforms, and they're large gas stations in space that have everything from fuel to new batteries to solar panel upgrades to all sorts of different things that our mission robotics vehicle will travel up to and then go to a client and make the modification that's required. So you got to decide what your servicing vehicle is going to be and how it can be optimally made. And by the way, part of that is what those things in the gas station are, what we call on-orbit attachable capabilities. You might want to actually, as part of your study, look at what should be on board that persistent platform for us to be able to go use in servicing another vehicle. So Northrop Grumman and Space Logistics will be there along the way to help monitor and provide some of the information that you will need. Some of that information will be briefed to you in tech briefs on what our capabilities are and what our system looks like. We don't want to give you the answer, though. So, because quite frankly, we think we have the answer right now. It's the vehicles that are flying. But you're really designing for something that's maybe next generation. So keep that in mind when you look at what we have and where we need to be in about 5, 10, 15, 20 years, and come up with a system that is optimal for you. Maybe you can design the space logistics vehicle better than we can. Maybe you can think of some technical advancements that we didn't 10, 15 years ago when we started this. Maybe you can make it cheaper some way, which is always a positive thing. Or maybe you can think of other applications that maybe we haven't thought of. So, universities are innovative, and I'm real excited for the students and research professors that are going to be part of this program to come up with your own ideas. Again, we'll be there to help guide you. We'll be there to give you some site tours if you're the winning person or a university that develops this system. And then you'll come into Northrop, whether it be our Gilbert operation where some of these vehicles are made, or our Dulles facility, to actually give us an outbrief on what you've done at the end of the year. Excited to see what you can do, and best of luck, and let us know what you come up with if you pick our project, which you should. Thanks.